Welcome everyone to today's webinar, Preserving the Past, Innovative Monitoring for Cultural Heritage, part of the BUILDCHAIN Webinars 2.0 series. My name is Uroš Bohinc. I'm a senior researcher at the Slovenian National Building and Civil Engineering Institute, and I will be your moderator for today's session. We are here to explore how cutting-edge technology is revolutionizing the preservation of our most cherished historic sites, inspired by the tragic 2019 fire at the Notre-Dame Cathedral. This webinar underscores the critical importance of preserving cultural heritage. We'll delve into the latest advancements in integrity assessment technology for heritage buildings, focusing on smart monitoring's motivations and objectives. Our expert speakers will guide us through various aspects of this important topic. First, there is Professor Juan Chacho Ruano from the University of Granada, and he will provide an introduction to the topic and showcase the creation and use of digital twins for historic buildings. And there is Branimir Rakic, founder and CTO of Trace Labs, and he will discuss the concepts of trusted knowledge and AI and how they differ from regular AI. And there is also Emilio Daroc Salazar, project manager and researcher at the University of Granada, and he will explain the technical details of data collection. And we have here also Stevan Nesovic, lead product engineer at Trace Labs, and he will join Professor Chacho in presenting a live demo of technology and data-driven preservation efforts at the Hospital Real in Granada, Spain. Today's session promises to be insightful and engaging as we learn about the role of data and smart monitoring and acquiring the knowledge needed for effective preservation of cultural heritage sites. But before we begin, there are a few housekeeping notes. This session is being recorded and will be available for later viewing. Please do submit your questions via the question and answers feature, and we will address them during the dedicated Q&A session at the end. Feel free to engage and share your thoughts in the chat, but please keep it respectful and relevant, of course. And of course, again, thank you for joining us today. Now let's dive into our first segment. Professor Chacho, the floor is yours.
Okay, thank you, Uroš, and also thank you for all the attendants for this this section. Well, first of all, let me share my screen. Sorry, I have some problems. Let me. Now it is. Sorry about this. Well, let's make the start. In this first part, I will provide an overview of the webinar, which is focused on, as you know, on cutting-edge technologies to preserve the past, and in particular, we will focus on the most innovative monitoring technologies to tackle the important aspect of the preservation of the cultural heritage assets. First of all, let me explain that this webinar is part of the BUILDCHAIN project. And here in the previous slide, you can see the different partners in participating in this important project. In my particular case, I am from the University of Granada. The objective of this project, the main goal of this project, is to create let's say a cutting-edge digital building logbook for buildings, of course. And we will put together different information from users, from actors, information about the building life cycle, including design, drawings, operation and maintenance data, renovation data, materials, all these aspects. And we will put all this together into the decentralized knowledge graph, which is, let's say, the special aspect of this project. We will have time today to talk about this particular technology and how this technology is useful to create a digital twin that can be somehow used to as the basis for a conversational model that we will showcase today. The project, this BUILDCHAIN project, has 5 pilots, meaning that we will show we will demonstrate the technology in 5 different real buildings. Today, we will see the particular applications of this technology in the Hospital Real in Granada, which is our pilot 1. This building is today the rectorate of the university, but it backs from the 16th century. It is an ancient building here just located in the center of the city in Granada, Spain. Just for you to have an overview, some pictures, nice picture of the building. The challenges that we have for this particular building and other similar buildings like this in Europe is, of course, the preservation of these important cultural heritage assets, but the preservation in a cost-efficient manner, which is an important aspect here. Most of the times, these assets, one of the problems, the main problematic here is the lack of knowledge about the real health state of the building. And the only feasible solution to solve or to tackle this challenge is to increase the knowledge that we have using our technology today. And this means putting together the state-of-the-art monitoring technologies that we have, covering structural integrity, covering different aspects of the building, but also treating this data, putting all this data together within state-of-the-art knowledge representation technologies. And we will talk today about, for example, decentralized knowledge graphs. We will put those on language models, etc. So process this information in the most, let's say, technological advanced way using this, today's artificial intelligence. So this is the solution that as a consortium we are developing for these challenges. In particular, the goal of the project will be to create this digital twin, and to put this digital twin, the information that we are generating for the building, in the shape of the origin trail decentralized knowledge graph, and somehow put on top different layers of trusted artificial intelligence to inform decisions about the building. So at the end of the day, we will have, let's say, an assistant to make better decisions on the maintenance, restoration, and how we should optimally manage this type of important assets. Well, as I explained before, the type of data that we will use, we will put in the format of these decentralized knowledge graphs depends on the different pilots. But in this particular case, for the cultural heritage assets in pilot 1, we will use data from the building, like, for example, building geometry, material and loads of the building, sensor data, ambient vibration data, displacement data, etc. And also we have algorithms that they will post-process this information and produce new information, new data. for example, about damage diagnosis, damage location, and also importantly, information about the actual material properties, which is something which one of these unknown properties of the building. So this data that is produced is also pushed back into the DKG. So as long as we are collecting new data and post-processing it, we will be able to enrich our decentralized knowledge graph, and then our models will be sequentially more predictive. Well, this is just to show that at the end of the day, we will be able to put together the physical reality, which is that which comes from sensors, with the computational reality of the building, and in between we are doing inferences. I don't want to enter into the minor details on these technologies. But through this inference, we will be able to, well, of course, to create new knowledge, infer new knowledge, which is pushed back into the DKG. But now my colleague Emilio is going to explain, to provide some details on the particular experimental campaign that we have produced into this building. We have been able to install permanent sensors there. And the process was very particular and even, I would say, funny. So Emilio will be now explaining the details of this. So Emilio, now I leave the floor for you.
Okay, thank you, Juan. Let me share my screen. There it is. Well, hello everyone. Thank you very much for inviting me to participate in this exciting webinar. Today I'm going to discuss about this initiative we are undertaking at the Hospital Real. As Juan said, this serves as the pilot one of the European project BUILDCHAIN. The primary objective of our pilot at the Hospital Real is to develop a comprehensive digital twin of the building. This involves automating data collection from sensors, conducting to an operational model analysis to get the natural frequencies of the building. This is, in other words, to get the dynamic behavior of the building, and there to infer the mechanical properties through Bayesian inference. But most importantly, we aim to make all this information accessible through the decentralized knowledge graphs, enhancing transparency and accessibility. We began by studying the material properties of the building and the structural drawings. This allowed us to model the Hospital Real and create a finite element model to understand the building's dynamics behaviors. We found that the primary model behaviors were mainly located within the hospital tower. With this understanding, we focused our experimental campaign on the tower of the building. We installed seismic accelerometers at key points across 2 different levels to capture the data on the building's response to natural oxidation forces. The setup was designed to monitor the tower of the building, allowing to analyze the data in almost real time and effectively capture the real natural frequencies and model shapes of the building. Our approach to the parametric inference, I won't go too deep in this part, but involves sophisticated yet intuitive methods. Initially, we assign a prior distribution of the parameters of interest, such as the Young modulus of the stone, for example. And this is a starting point of our Bayesian inference process. Using the final element model and of the hospital and the observed data from our monitoring system through an iterative method of Bayesian inference, our goal is to get the posterior distribution of the parameters. This iterative approach ensures that our model continuously refines itself, enhancing its accuracy with each cycle. Our data management architecture is straightforward, ensuring efficient and secure data handling. We start by collecting the data from 6 sensors, which is managed through our acquisition system. At the Hospital Real, we use a Python script on a notebook to gather this sensor data and store it in an SQL database. To enhance this connectivity and integration, we set up an Apache server using Chomp on this notebook. This server hosts an API REST, which is a service that allows the system to communicate over the internet in a simple and standard way, facilitating requests and responses between the Hospital Real and our computational servers at the University of Granada. This setup enables the transfer of data, which is then processed in the university. The results are forwarded to our virtualization server, allowing us to monitor the data in real time through the dedicated website we mount, which I will show you shortly. Let me here. Well, here as you can see all the sensors at the Hospital Real. You can choose which sensor you want to see, and this is in real time. Right now we are only showing 20 hertz of data because we are decimating the 200 hertz. We are really gathering, and let me turn the presentation on again. But this is a traditional way of getting data, but how we do the transition from a traditional database to a knowledge graph? Well, this is by creating knowledge assets that links and establish the relationships within the knowledge entities. In other words, we identify the entities and relate them to each other to place them within a context or an ontology. From now on, our colleagues from TraceLab will discuss this in more depth. So, thank you very much.
Oh, thank you, Juan and Emilio, for the exciting presentation of the structural health monitoring system that you set up at the Hospital Real. Of course, the gathered data is important, but there is also a quite important aspect of how to handle the data and how to handle the validity and trusted knowledge. And these are the things that Branimir will tell us more about. So I'd like to invite Branimir to tell us more about the origin trail and trusted artificial intelligence. Branimir, here you go.
Thank you, Uroš, and everybody. This was a really great intro. So I'll share my screen and I'll just continue explaining what this actually is, these knowledge assets, and how we work with them. So I just need a thumbs up from somebody that you guys see it. I guess I saw a thumbs up. Awesome. So I'll try to be very brief, and I'll share some more links for those of you who want to dive deeper. And it was great to start with a use case where you could see basically experts in the industry really driving this concept to the basically the maximum possible right now with technology and bleeding edge, really in terms of AI and reasoning, with directly monitoring a building. And what I'll dive slightly into is how we would create a more generalized construction digital twin, and what will be the bottom line, what type of technology stack, rather set of layers that we would need for that, and why Origin Trail is part of that stack and can help you if you're building similar similar systems. So without further ado, I'll just jump right into it. Clearly, though, to understand why a certain solution is the most applicable one, we have to go back to the problem. So I'll try to explain in a very quick couple of sentences what we see today. So today there's a lot of building data all over in various different, let's say, data stores. Those could be legacy or even modern, but it's very hard to interact with them because they're all pretty much scattered around and they have different shapes, if you will, different formats. So because of that, we also have limited insights into complex topics, such as the ones we've seen just now. So it's complex topics by themselves also require domain experts sometimes to understand what they're looking at, what kind of information we're actually seeing. Then because of these repositories are separated, it's actually the connectivity is quite often a problem. They haven't been designed for connectivity in mind. Therefore, if you have scattered data on something in different places, it's very hard to get the whole picture. And even if you somehow do, it's actually hard to verify that data and information. And finally, we get all of this amazing new AI advancements coming out, but they actually cause problems of their own as well. For example, if you go, and I'm sure all of you listening to this webinar have tried ChatGPT by now, and probably you heard of hallucinations. Well, it's very easy for it to hallucinate because it's this neural form of AI that essentially has hallucinations as its feature. It will always give you a confident answer, right? Even when it doesn't know the answer. For example, ChatGPT hasn't been trained on data about events from yesterday, like, I don't know, a tennis match in Roland Garros. It wouldn't know those results. But it would confidently spit out maybe a result. And at the same time, they also capture so much data that they endanger data ownership globally. So we all know these models get trained on basically the whole internet. So it is quite a problem, and we need means to tackle that. So what we want to see really, what does a good tomorrow look like, is instead of making it hard to interact with data, we want to have simple humanized access. So, ideally you chat with some AI agent via natural language. What we want to really do is we want to have these digital twins autonomously predict what's going to happen and notify us, but also do advanced reasoning as we've seen just now, but not do it in a hallucinating way, rather do it based on the knowledge of that specific domain. We want to be able to fetch information from multiple repositories, not just like scattered pieces of it, and then obviously have a level of verifiability of that data, ultimately reaching also data privacy, so that we solve for data ownership problems, and we basically manage hallucinations at the same time. So from a conceptual overview, I'll try to show a vision for what the solution like that actually looks like and how it works even today. At the end, we'll actually see a demo of such an application live. So basically what we want to see is a world without hallucinations, with information provenance. We don't want to have costly retraining of AI models, ideally, because that costs a lot. We want to have multiple data sources, remain owners of our data, and have data privacy. And this is what the Origin Trail decentralized knowledge graph has been designed for. There's many different companies already using it. I won't dive too deep, so I don't spend too much time. You can find a lot of this information on the Origin Trail website, but just to mention a few retailers in the US, such as Walmart, Target, Home Depot, cover 40% of US imports with Origin Trail. Swiss Railways and their partners is using it for many years now already to track essentially digital twins of trains and parts in their supply chain. There's a bunch of food and beverage companies, pharmaceutical companies already using it today in production. So basically, you can check out much more about this on the Origin Trail website. And not just the companies. Actually, there's a lot of companies using technologies which we're talking about today, actually for many years. So Google, Netflix, Amazon, all of them actually use knowledge graphs under the hood. Anytime they recommend you a thing to buy or a show to watch or in search results, depending on their different use case. For example, IKEA uses knowledge graphs when you're purchasing for example, a couch, it actually uses reasoning to understand that maybe you also need like a cushion or maybe a lamp next to a reading lamp next to that couch. And if you've been purchasing on IKEA online, probably you've seen something like that. Well, that comes from a knowledge graph. All of these companies actually extract a lot of value from the knowledge that is present in those knowledge graphs that actually collects information about not just their products, but also the users and pretty much anything they can amass into the knowledge graph. And that's, like I said, been going on for decades already. So what we're actually seeing here is that knowledge is the asset class for artificial intelligence. It enables finding all those very powerful inferences and insights from scattered data. And therefore, Origin Trail, the core component, the core primitive, is something called a knowledge asset. It contains these 4 elements you see on screen, but basically the data in various forms, be it vector embeddings for that is more a neural shape, or graph data, such as knowledge graph data, which is more of this symbolic shape, as well as verifiability proofs, and even a token on a blockchain that is that embeds all of this knowledge into an ownable structure, not a monkey picture, but actually a knowledge NFT. And when you actually want to build a solution like the one we'll show you, a trusted solution that will enable you to have an AI agent with a digital twin of any object, such as a building, for example, all you have to do is like basically 3 steps. One, first step is to assemble data into knowledge assets. So basically collect all that information that you can find, be that information about the BIM model, information from sensors like we've seen or we'll see in a bit, bills of materials, various events, standardized events such as EPCIS events, and so forth. Basically, you would create a knowledge repository from these knowledge assets. You would put them into the decentralized knowledge graph, including labeling which data you want to remain private in your knowledge repository. And you can go do that both manually and automated. And you can even enable multiple contributors. But once you get all of these knowledge assets in one place, basically you're ready to go. Step 2, you can basically already attach an AI application on top, and you can see what kind of queries are coming in to your repository. That can be both questions, but also can be very sophisticated queries about elements of the building. We'll see that in a bit. But the point here being is that you go into an iterative mode. So you monitor what's going on, you identify what's missing, any gaps, any answers you cannot get. You find the new knowledge, you add more knowledge assets, you test, and you basically do the cycle. Finally, once you have your own repository working, you can connect it with other repositories. So you get these multitude of repositories in a decentralized knowledge discovery network. And that's actually under the hood. There's a framework called this Decentralized Retrieval Augmented Generation Framework, which enables basically a neurosymbolic AI system, combining LLMs, this neural system, and symbolic AI, which is knowledge graphs, so that the value propositions you really get is we have a knowledge graph grounding of the LLMs. So hallucinations are minimized or completely eliminated if implemented well. We get information provenance for all of these knowledge assets via the blockchain, because all of the inputs and publishing transactions are visible there in a transparent manner. We also get ownership via this NFT, and data privacy, as I mentioned, because it's all configurable on the user side. Finally, what we get is a multi-party really system, a knowledge marketplace. So pretty much designed for the challenges we looked at in the beginning of this. And since there's not a ton of time to dive into all of these concepts, and I think I'm already a little over time, there is a paper that describes this in much more detail that you can check out. It's still in pre-publication, so feedback is also very welcome. If you would scan this QR code, you would basically get right there. The paper basically talks about the convergence of these 3 technologies: artificial intelligence, which means LLMs and knowledge graphs, the internet stack, and crypto technologies, meaning all of the cryptography that's used for the value propositions we just looked into. And it provides this vision for a verifiable internet for artificial intelligence in which multiple different ownable knowledge repositories containing digital twins of buildings or construction processes, manufacturing processes even, or any type of really knowledge domain expertise that can be quantified into knowledge assets, can be used to build trusted AI on top. And having that said, we're actually going to take a look into one such example very soon. But this is pretty much where my presentation ends. So I'll take it back to you, Rosh.
Thank you. Thank you, Branimir, for this insightful presentation on the importance of the trusted data. We will now, as already mentioned, continue to the second part of our webinar, and we will see or show an actually cool demo where these concepts will be shown and presented and demonstrated. Let's leave it to Juan and Stevan, and they will show us the demo and walk us through.
Okay, thank you, Virus. Well, I will share my screen again. I will hope everything will work now. Okay, can you see my screen, right?
Yep.
Okay, good. Well, we will showcase all the concepts that Branimir has been explaining very nice, and also we will show how this can be applied to our building that we were discussing before, the Hospital Real in Granada. Remember from our prior conversation about the building that we already have sensors there. We have some data about the building. So we will see in this demo how we can retrieve this information using this somehow chat GPT for the building. So this for sure Branimir will explain this and also Esteban in a better way. But just for the rest of you, I would like to stress the idea how we can somehow maintain a conversation with the digital twin of the building and ask questions about it. For example, let's start from the beginning. The first question can be a generic question, like, for example, what can you tell me about the Hospital Real? Just something like this. Okay, so we presenter. So he's thinking a little bit. Okay, so here we are. So it's provide the generic information about the building. It's an ancient building in Granada, built in the 16th century, etc., etc. And now it serves as the rectorate of the university, everything. So it's let's say a generic information. Here, for example, we can see that the building has a permanent structural health monitoring system, which was installed in November 2023. So this is a nice piece of information. So let's try to see if the system can give us more information about this monitoring system. So if you want, we can continue asking about this particular case. For example, can you tell me more about the monitoring system? For example. Okay, he's thinking. All right, so here we are. So it says that the building has a number of sensors. In this particular case, 6 accelerometers with the information about the model, the type of the sensor, the sensitivity, different technical details. Here also we have information. The system gives us information on the way this sensor are being interrogated. So here, for example, we have information that this acceleration data is being collected in a real-time continuously, let's say, real-time way. So it's well, it's a nice piece of information. Also, what you can see here that the system say that the collected data is stored in a database and then post-processed using operational model analysis to obtain these natural vibration modes of the building. So it's a good piece of information, which of course is too technical. It's only for, let's say, for structural engineers. But well, just Esteban, just one question for you. If, can you explain to the audience how the system is able to collect this information? How all this work?
Thanks for the question, Juan. So basically, on the right side of the screen, you can see the section called Source Knowledge Assets. Basically, this section explains to us which knowledge assets are being used basically to formulate the answer that you can see on the left side. In this case, we have 3 knowledge assets. You can see all of the titles of knowledge assets. You can see the issuer. For this example, Chase Labs is the issuer because purposes of the demo, basically. But let's say in the real world scenario, University of Granada, who actually put the sensors, will be probably the issuer of the data. What we also can do here, we can also see the content of some of the knowledge assets. So maybe you can click on this button so we can open up our DKG Explorer app, where you can actually visualize the whole knowledge graph. You can basically see how the data is being connected. And beside that, you can also have other useful information like activities on the knowledge asset. You can also see other important information for data verification in the next steps. Or you can see, for example, on which blockchain your knowledge asset is created. So if we get back to the ChatDKG UI, we can conclude basically that every answer that ChatDKG provided is based only on available knowledge assets inside of this knowledge bank that we are creating now.
Great, great, very good. Well, no, it's super nice. Here, for example, I am curious because the system provides information. It says that we have sensors and the sensors are continuously collecting data. So I am curious about this data. So, for example, why not asking the system? The next question can be, for example, very simple. Can you give me real-time sensor data? Let's see what happens. Thinking, all right, good. So this is the response. It says you can access real-time sensor data in this particular link. So let's press the link and see what happens. All right, good. We have, remember the previous presentation from Emilio where he was explaining the database where we were collecting this data. So this DKG is just going to the direction where this data is being collected in real time. So you can see where we in different the different acceleration data for the different sensors. So you can of course play with this. Of course, the horizontal axis is the time, so that's why the figure is dynamic. Somehow the vertical axis is the acceleration of the building. The sensors are located into the tower of the building. That's why you can see this vibration. We have different algorithms by which we post-process this raw data, this acceleration data, and we convert this data into natural frequencies, which are the frequencies of the fundamental vibration modes of the building. So this is, let's say, a technical information for structural engineers, and you know this frequency data is useful to detect damage. So here in this plot, for example, you can see the trace, so the evolution of the different values of the frequencies over the time. So this is a good piece of information if we want to detect damage, because typically when there is any damage or any integrity change into the building, it is manifested into changes into these frequencies, in particular to the higher frequencies. So here is, and then the last step on the structural integrity assessment is to convert this frequency data into parameters which are highly related with the let's say structural integrity of the data. But if we just go back to the demo, I don't want to enter into the technical structural details of the building. given that we have data about the frequencies, I am just curious. So if you want, we can go to the next question, which can be related to those frequencies. For example, something like I need average values for the natural frequencies of the building during the day, for example. Thinking. Okay, so you remember that in the previous in the database we had time varying frequencies, and now we have averages. And this average was collected in a particular day on the 19th of May in this particular case. And here you can see the values, the average values of the four vibration modes that we have been able to detect into the building. So.
Juan, sorry for interrupting. I have maybe one question for the sake of everyone on the call. Why are there differences between measurements during the day and the night? Is there any difference?
Good. Well, this is a good question. In fact, it's a curious question. Yeah, there are differences in the frequencies during the day and the night, because somehow the building is different in the sense that as a consequence of the temperature, the building somehow elongates, and then that changes the shape of the building somehow, and this is manifested into changes into the frequencies. For example, typically during the night, these frequencies are a little bit higher than during the day. So it's important to collect this data during the day and during the night, because if we want to use these frequencies to detect damage, we need to understand whether or not this damage comes from actual damage, or is just let's say a change as a consequence of the temperature. All right, so this is just the reason why we store this information, including the information of the time, day or night of the. All right.
Thanks.
Good. No problem. Now, well, we've seen how we can collect data, different raw data, technical data, generic data of the building. Now, I have one question for you, Esteban, which is how we are sure that the system is not hallucinating. In other words, how we are sure that this information, these responses are accurate.
Yeah, I think the best way to answer on this question is to basically show how the system works.
Right.
So, for example, we can use building materials as example. We clearly know that there is no information about the building materials inside of the hospital real building knowledge assets. So maybe we can ask some question, for example, give me information about building materials. So if you can do it, it will be great.
Give me information.
Yeah, since we don't have this information in the knowledge asset, we should not expect basically that ChatDKG returns us the proper response.
All right. Yes.
Yeah. So based on this answer, we can clearly see that ChatDKG don't have this information, and that it will not basically make up the answer, so it will not hallucinate. But what we can do here at this point, we can add the knowledge that we need regarding the building materials, and we can add it pretty easily and quickly. So maybe I can share the screen and show you how this can be done. Okay, can you see it? Yeah, so
Yes, we can. Go.
This is basically our network operating system, our application, which I will be using basically to create a knowledge asset. What I want to mention here is basically that users don't need to use only network operating system for creating knowledge asset. You can also create knowledge asset using our publicly available clients, which are now available in the JavaScript and Python. It is basically pretty easy to do it. You basically install the DKG client as any other package. You can initiate the client. You can, of course, prepare your data for your knowledge asset. And basically in one line of code, you can create your knowledge asset. It will return you basically the public assertion ID, which is used for data verification in the next steps that you can use in the future, as well as the UL, which represents, let's say, like a global unique identifier for your knowledge asset that you can use anywhere on the DKG to access your data. So we can get back to the NOS. Okay, we have a problem with creating this knowledge asset, so I will try to do it once again.
Can you show us how the knowledge asset looks like? Like what are you creating it out of?
Yeah, that is a good point. Basically, this is how the knowledge asset look like. We can see basically based on the data that we are connecting this knowledge asset to our building. This is example, of course, identifier for the Hospital Real. And we can see the UL, which is global identifier of the Hospital Real building. Below, we can see the images that we are attaching, basically providing like images from official documentation of the Hospital Real, as well as the section with the materials. So every basically side of the building has a couple of different materials that I will be showing in the next step. So let's wait a couple of more seconds for the asset to be created. Okay. We can see there is a global identifier, meaning that knowledge asset is being created. So let's get back to the ChatDKG application. So I will ask basically the similar question that Juan asked. So can you give me information about the building materials? And now that we basically added all the knowledge to our knowledge bank, we should probably get the information. Yeah, as you can see here, we can see all of the sides of the buildings with all of the materials. We can also see, as I said, official documentation of the building attached, where you can also in detail see which materials belongs where on the building. So based on this answer, and of course this answer that we previously showed without any data about building materials, we can conclude that ChatDKG will not definitely make up the answer or hallucinate, but it will basically create an answer based on the available knowledge assets inside of its knowledge bank. So
Good.
yeah.
Good, Esteban. Super nice. I'm really impressed about the way we have been able to create new information in real time. So thank you for this.
Perhaps a question, Stevan. So if you share the screen back, can you show us the exact knowledge asset that you created?
Yeah, of course.
That's on the list, right?
Yeah, of course. This is basically the knowledge asset.
Yeah, I mean in the answer on that question you just posted. So
yeah, this is basically the knowledge assets, Hospital Real facade. So we can open up the knowledge asset and see basically all of the data. This is how it looks. So maybe we can zoom in a little bit. So you can clearly see there is a connection with, let's say, main node, materials being used, and basically all of the materials with descriptions like brick on which basically place of the building this material is used. So this one is on the, let me check, northwest west side. So basically everything that you can see in the answer is basically extracted from the knowledge graph.
And effectively, you have just answered the question that was posted in the QA from Noemi. So cool. Awesome. Perhaps a note here is what you're looking at is actually based on standards as well. So the knowledge graph representation is effectively not like a completely W3C compliant implementation based on the RDF standard. So that's why these URIs and UALs, which are an extended form of URIs, are being used, including standards by W3C that pertain to the blockchain layer. So that means decentralized identifiers. If you've seen that DID shorthand in one of those URIs, that comes from that W3C standard. And effectively, the variability of the information follows the verifiable credentials data model, which is another W3C standard. So the big maybe thing we didn't really mention so much during this webinar, which I feel it's important to say, is that all of this is actually open source and built on open standards. So anybody can create knowledge assets. The decentralized knowledge graph itself is also an open network completely permissionless, so anybody can run a node in the network and have their own knowledge base in it. You can just follow the instructions on the website, the official documentation, and install it on a server. And there you go. You can start creating knowledge assets. You can even pick different blockchains you want to use. So the system has been designed as well as is being built under this principle of neutrality, because it enables the widest possible sense of choice. The ability, like I said, to choose blockchains, to choose different types of elements for implementation, but at the same time also like following a set of standards so that we have a unifying language that actually enables data aggregation across different repositories, enables connectivity in this web of data that actually these standards were designed for. Okay, I hopped in. I guess we're finished with the demo, right? So I guess we take it. Uros continues, or who is the next one?
Yeah. Okay. Thank you. First to Juan and Stevan for this great demo and really cool features. But of course, as any new technology, it raises some issues, some questions. So in this demo, you just showed how we can add additional information about the building to the origin trail DKG and connect it to the existing knowledge asset, and how to retrieve this information with the help of AI. But what about when we have a lot of information, like a massive amount of information about, let's say, I don't know, an airport? How can we feed this information into the origin trail DKG? Is there an automatic way to do it?
I can take this one. That's a really good question. And actually, the point of the DKG itself is that it doesn't necessarily contain all the information in itself, rather that it actually maps that information. And what do I mean by mapping? Well, one of those examples we've just seen. So on the building, on Hospital Real, we have knowledge assets that integrate different pieces of information which might not necessarily be in the DKG itself. For example, the sensor data we've seen, or rather the frequency modes of the buildings, the charts that were shown on screen, come from a stream of information. And that stream comes directly from the sensors, basically. So it's real-time updated. So the access to that stream is available, obviously under certain conditions, depending on you build it. As well as there's an ability to take snapshots of those results if interesting for discovery in the DKG. So ultimately speaking, the idea of it is not becomes like the one and only store of data in the world, rather what knowledge graphs are good for, which is discovery, search of information, so that when you actually have a huge amount of information, that you're able to discover where it is, in which data repository it sits. And naturally with certain level of privacy. So not all of the information in the world, actually quite a lot of it, is not for public consummation, right? So we wouldn't expect, like, for example, an airport, as you mentioned, to publish some very sensitive information into the DKG because it might be something of a security risk for that airport, just as an example. So it's not designed as like the biggest database in the world, but rather is designed as the biggest knowledge graph in the world, which means it maps concepts and objects, and then we can discover information about those objects really somewhere else. And when it comes to generally the scale, in terms of scaling Origin Trail as decentralized knowledge graph, a big benefit of the scaling is its design, its actual distributed design. So it's contrary to, let's say, a more consensus-oriented system like a blockchain, where scalability is a pain point because of design. It's designed to be a bottleneck so that it provides security. The DKG, which is a network of its own and connects to multiple blockchains, is actually not a consensus-based network. So it doesn't have these limitations of consensus, meaning the more nodes, the more machines you add in the network, the more capacity it gets. And because of the design of the networking, the system applies a peer-to-peer networking system. This can actually scale quite a lot because it has a logarithmic, basically a logarithmic addressing system. But that's a very, very brief answer. And I guess because we don't have that much time and have a lot of questions, perhaps I can direct everybody else to the official documentation of Origin Trail, and also to feel free to join us in Discord or Telegram and ask also more questions there.
Thank you, Branimir. I think that, as you said, this answer needs some deeper understanding and further exploration. But still, I think you pointed out nicely that what was the difference between a big, massive database and the knowledge graph. So I have a question for Juan. Maybe what would, in your opinion, an ideal digital twin of a building look like? What information would you like to see in the Origin Trail DKG?
Well, thank you, Euros. Well, this is a very convenient question. First of all, I have to say that most of the industry today in Europe, most of the countries, they are regulating the way we are presenting, let's say, the information of the buildings, because we have created a new technology which is called VIM technology, VIM, by which not only the geometry information, but also the information from all type of, let's say, elements of the building, materials, sensor data, everything can be represented in using this technology, this format. So my let's say my first response would be in that direction. So we have this technology, and we cannot be let's say beside that. Now, here I open up another question. I respond this with another question. So the point is, we are creating this digital twin. We are putting together all this information on the DKGs because, as Branimir has explained very well, they are the essence to put other artificial intelligence techniques on top to collect more data and to create new knowledge. Now, the question is how this is just an open question. I don't have a clear answer. So the question is whether or not our DKGs, our knowledge graphs, are going to be somehow inserted or embedded into the information bank of these BIM models, or by the contrary, the BIM model would be just one node, one of these nodes that we have seen into the DKG. I really don't know. But what I know is that the technology, the industry now is looking at these BIM models, and my understanding is the shape of the digital twins for the buildings somehow should go in that direction. In fact, in the consortium, we have an important BIM provider, technology provider, which is Bexel. And that's why this is one of the also one of the open questions into the project. So I don't know if I got the deterministic response, but there's still it's an open question.
Thank you, Juan. I think that we have come to an end of today's presentation with this, and I think it's time to devote to open the question and answers session. We have a couple of questions. We'll just a second start with the first one. Here is a question: are there sensor data verifiable? Can you show us the schemata of some exemplary DIDs? Why would you use NFTs instead of DIDs? Okay, so this is, I guess, a more technical question.
I can take this one.
Yes. Okay. Thank you. Thank you, Branimir.
Actually, 3 questions, but basically, I'll try to get quickly all of them. Essentially, so the question was, is sensor data verifiable? And there's a couple of elements to this answer, let's say, but ultimately verifiability being enabled by the DKG is done on the knowledge asset level. So each knowledge asset has an own issuer, and an actual cryptographic proof that's stored on a blockchain, so that anybody who queries this knowledge asset is able to, by themselves on their machine, without like any other authority having to verify it for them, verify the integrity of this information. This is a basic primitive that enables you to identify that this data was published in a certain at a certain time by a certain party in this particular form. So if it has been changed somehow on the way, you will immediately be able to detect it because of the algorithms that enable this, which are these cryptographic proofs. And basically they're computed on the receiving side, if we can say it like that. When it comes to sensor data, because it's a stream, the stream can also be made verifiable in multiple ways. Either if the stream is plugged into an oracle, which is what we are actually working on within the project as well. And you can also see how that is done with Origin Trail and one of the most popular Oracle systems called Chainlink. There's an actual tutorial on that on the website, and oracles need quite a few minutes to be explained, but essentially, if I were to say it in one word, you can consider them as a way to add additional verifiability into some streaming data. Now, that's a very simplified way to look at it, because the question here being is what kind of streaming data? If the streaming data comes from multiple different sources, then aggregating that via some Oracle network is very sensible to do. If the data comes from one source, or which is controlled by one party, such as in this case, one company, let's say mapping sensors of a building, decentralizing or reading the same data from multiple times from the same source might not make a lot of sense. So rather, it might make more sense to make snapshots of that data in terms of sharing the historical information from that stream, as well, again, in knowledge assets, so that you can actually query in batch sense this information, let's say on a daily basis or on an hourly basis as knowledge assets, and then actually establish verifiability in the sense of knowing that this was actually time-stamped and cryptographically signed by a certain party. So there's multiple ways to establish verifiability here. There was a question of why NFTs versus DIDs. Well, actually, it's both. It's DIDs and NFTs at the same time, though depending on what thing we're talking about. So the NFT represents the ownership of the knowledge asset, which is identified by its own DID, as well as the issuing party, who was the publisher of the knowledge asset, also identified by their own DID. And I believe there was another part of it about showing some schema. Basically, I would direct anybody who's interested in that to dive into the docs, and if also interested to go further, super happy to answer even more questions in the more technical questions in the Discord or Telegram group. And from what I've seen, that the links for that have been posted in this chat. So that should roughly cover those three.
Okay, thank you, Branimir, for the extensive answer. I hope it was served properly. There's another question. Can you do something more than just information browsing, and what? Who will tackle this one?
Yeah, maybe Juan, you're the best person today. I was about to suggest you take it, but I think we've seen quite a lot more than just browsing information here. I guess the reasoning is one of the things, if I were to answer, would be something I would highlight. But I'll let you do it because you're the expert. I'm not nearly an expert in construction.
No, but yeah, well, thank you, Branimir. If I got the question, the point, as you mentioned before, is the reasoning capacity of the system. So we are not just querying data. Remember that we have models. So for example, when we convert raw acceleration data into frequencies, this is something that happens in a different, let's say, computer, to say something simple. Then when we ask about frequencies, the system is able to know that there is the question is about something which has been post-processed. It's not just looking for existing data. It's something that happens. So we have this capacity to create new data, to post-process in almost real time this new data, and to show this new data. But this is something that happens, let's say, behind. This is something that happens on, which is not on. In other words, it's not just looking for existing data. We are also creating the data as long as the system is querying somehow. I don't know if this is the right answer to this question.
Yeah, thank you. In any case, it has been helpful to understand the capabilities of the knowledge graph. But as being a very new technology, of course, it takes some time to grasp all the capabilities of it. So therefore, I guess it's quite okay if some of the questions remain still partially open. There is another question on BIM, and it goes like, is there any connection between these knowledge assets and semantics of BIM, like building information model?
Yeah, well, Brani, perhaps I can make a first version of this answer and then you can continue. Well, as I explained before, Noemi, this is something that from my point of view, it is still an open question that we have. I can say yes. I don't see any reason why we cannot fuse, let's say, or embed this information within the semantic of BIM, because basically BIM is based on let's say, the groundings of BIM is also based on these knowledge assets, and I don't see any reason why we cannot do this. But it's still an open question, because another way to see this is we can think on let's say on the other way, which is embedding the BIM information within a particular knowledge asset of the DKG. From my point of view, it depends on the value added by the BIM model. Some BIM models are just geometry representation of the building. So in that case, perhaps the relevance of the information within the BIM is less important than the other information contained into the DKG. And then in that case, the DKG can somehow phagocytate, or let's say embed the information from BIM. In other cases, the BIM is very complete and you can find tons of information about the building in this BIM model. And that, in that case, perhaps is a better option to fuse somehow these two knowledge assets. But still it's an open question. So we need to discuss as a consortium and also as a community, as a scientific community, how to plan this development. Is my opinion.
Okay, thank you, Juan. As already said, this is an open and active topic, so it's still developing, and we'll be able, and the whole point of the BUILDCHAIN project is to work on this questions, and hopefully this consortium will be able to provide some answers and some guidelines in the future, but there is a lot going on in the world currently on this topic, so it's not only us working on this, and so let's keep on tracking the development and see how it goes. And we have still one question to answer, and this is which blockchains have been used during this webinar and which info is stored in them, hash or hash for data provenance? Okay, I think Stevan or Branimir are the most qualified here to...
Yeah, you want to take that one, Stevan, or should I?
Yeah, I mean, knowledge assets are being created on the NeuroWeb mainnet blockchain. And beside hash of the data, we are storing also the token ID, which is basically NFT of the knowledge asset. We are storing who is the issuer and the owner of the knowledge asset. So a couple of different informations which are attached to the knowledge asset itself. So hope that...
Just with one slight addition, when you do this, you can pick different blockchains. So currently supported are basically blockchains from Ethereum and Polkadot ecosystem. The NeuroWeb that Stevan mentioned is a Polkadot parachain. But also you can do that on Ethereum on Gnosis blockchain, which is another one on which is quite cheaper than Ethereum, which is why it's used quite a lot and actually has a very long-standing productive history. And we're actually pursuing more integrations. So just yesterday we announced integration with the Base blockchain, which is another layer 2 blockchain on Ethereum. Basically, the design of the DKG is so that it can connect to many different blockchains, and we're looking for, I would say, partners and use cases where integrating with another blockchain makes sense, where people actually are building something useful and there's activity and demand. So if you are interested in building with DKG and with a specific blockchain, do reach out to us. We'd like to hear what you're working on and see how we can help, and we can potentially go into the direction of integration. There's public RFC. Basically, the Origin Trail ecosystem has its own set of RFCs that you can take a look at, requests for comments. One that describes this is also present. I believe it's RFC 17. So you can see pretty much what it takes to just trigger this process to go into integration for another blockchain, if you're interested in doing that.
Okay, thanks, Branimir. Just as we were about to close this Q&A session, there was another question posted. I think it's interesting enough to take it, and I think we still have some time. This is, if I want to add new knowledge assets, does that cost me anything?
Yeah, I can also take this one. Yeah, so
Yeah.
basically, publishing a knowledge asset incurs a small. So the point of this fee is to actually cover the cost of the system. And it's contrary to, let's say, using something like Web2 cloud infrastructure like Amazon, where you would pay, let's say, an invoice at the end of the month for all of the servers you're using. Here, the idea is that you pay as you go. So just as you pay for a transaction on a blockchain, you would pay for a knowledge asset, some small fee to include it into the DKG. So that would be a very short answer. Much more detailed answer can be, again, found in the official documentation.
Okay, thank you again. Thank you all the speakers. Thank you everybody who were present. Thank you for joining us today. We hope you found the webinar informative and engaging. And if you have any further questions or feedback, please feel free to reach us out. And have a great day. Bye.
Bye, everyone.
Thank you. Bye-bye.
Bye, everyone.
Bye.